the engine was removed, the fuel tank was removed, and instead of that, we use a retrofit kit.
Because why we are doing that is that we are trying to support Indian companies, because our whole idea is revolving around AtmaNirbhar. Our target is to have 100% Indian components, Indian parts. That is where the whole game is.
That's amazing, because we are actually building a AtmaNirbhar Bharat while decarbonizing India's energy footprint. I think there cannot be a more inspirational and a more strong growth story like this.
We have a wind, solar and the biofuel combined together, and for one single output, which we are using for our electric vehicle charging. So assuming that 1 liter of petrol costs 100 rupees, so 80 rupees is going out of your pocket to the Gulf countries.
It's a win-win situation. You are saving on the carbon footprint by not scrapping a car and also retrofitting a car from a more emission, giving a more emission to a zero emission car.
Welcome back to another amazing episode of the Lairenlakpam Show. This episode is in collaboration with CSIR Indian Institute of Petroleum. In this collaboration, you would see a series of 8 episodes featuring eminent scientists from CSIR IIP who are actively working to build an AtmaNirbhar Bharat while decarbonizing India's energy footprint. I believe these scientists are the face. These scientists are the ones who are leading India, who are actually building an AtmaNirbhar Bharat while decarbonizing our energy footprint. And in today's episode, we are speaking with 2 scientists, Mrs. Poonam Gupta and Dr. Robindro, who have actually created an EV Retrofit Kit and also a multi-energy source hybrid charging station. I hope you enjoy the conversation. While you do that, please don't forget to hit the subscribe button. Welcome Dr. Robindro and Mrs. Poonam Gupta on the Lairenlakpam Show. So today we are actually talking about the technology that you guys have been working on, the EV retrofit kits and the hybrid multi-energy source hybrid charging stations. So I really want to start with that. Why did you actually build this EV retrofit kit? What was the need for it?
So these vehicles, there's a policy that these vehicles have end of life. They need to be removed from the road after a few years as per the policy of the government. So we thought that the cars are in good condition and they're supposed to be removed only because of the engines or because they're fuel-based car. So the thought was that we can increase the life of these vehicles because otherwise the car is in good shape. So the engine was removed, the fuel tank was removed, and instead of that, we use a retrofit kit that consisted of motor and the battery. So using that concept, we are making a better car which is giving you zero emissions and which is probably more efficient than the car that was previously used. So, and also you're saving the energy that would have been used to scrap that car. And actually there was no scrapping policy in place when this thought came into our mind.
How long ago was it?
This was in the year 2015-16. So that time there's no scrapping policy also. So it's just now that it has been introduced, but still you do need to have energy to scrap a car.
Yes.
So it's a win-win situation. You are saving on the carbon footprint by not scrapping a car and also retrofitting a car from a more emission, giving a more emission to a zero emission car. And also you're saving on the running cost of the car. The operation value we had calculated, there's a vast difference between the operation value as well. So it was a win-win situation for the user. That was the concept behind making a retrofit kit and converting a diesel or a gasoline-based car into an electric vehicle.
And coming to the second point of having multiple power source for EV charging, because once we have the electric vehicle, people always tend to have argument that power is coming from the coal plant or thermal power plant. So then it is right in some sense, and to have a green technology cycle, we thought that why not we harness the renewable energy source like sun, wind, and the biofuels and combine all together to have a multiple source. We call it hybrid energy system. Then multiple input, then single output for EV charging and the domestic use. So for us, it is used for the EV charging. Right now we have a demo operational unit. It is already operational. We have a wind, solar, and the biofuel combined together, and for one single output, which we are using for our electric vehicle charging. So that is the whole idea of having a complete zero carbon footprint, additional zero carbon footprint to charge EV, so that it will give an answer, one of the answers to the coal plant and thermal power plant based electricity. So that is where we want to make a complete cycle of this green technology from the electric mobility point of view. And the coming back to the first point, and I would like to add what Madam said. And India being the one of the fast developing country in the world, so India imports around 80% of its total crude oil consumption from other countries, mostly from the Gulf countries. So 80% is very huge amount of energy import. So government's agenda is that to reduce the import energy bill. So how do we reduce the import energy bill? Because we have to replace this fossil fuel based energy consumption by some other alternative or some other alternative energy. That is where this renewable energy, then the vehicle which consumes no fossil fuel, this all comes into the picture. 80% is something like we talk in terms of commercial. So assuming that 1 liter of petrol costs 100 rupees. So 80 rupees is going out of your pocket to the Gulf countries. It is a huge amount of money. So that's why government is emphasizing on the alternative, mobility or any other energy technologies. That is where we are trying to align our technology or our research with the AtmaNirbhar and the import substitution policy of government. That is the whole the overall, you can say, abstract.
I think that's amazing because we are actually building a AtmaNirbhar Bharat while decarbonizing India's energy footprint. I think like there cannot be a more inspirational and a more strong growth story like this. But while we are doing this, like there are a lot of concerns regarding EVs. Like, and as you people being the principal scientists behind the technology, people feel that while I'm taking my EV car, what if the car stops in the middle of the road? Like there's an issue with range anxiety. So how are we going to like handle that? Like, do you think that it's solvable?
Definitely it is solvable because charging infrastructure is now coming up in a very big way. FAME 2 scheme has supported charging infrastructure, and this charging infrastructure is also improving day by day. And there are a lot of ways we're trying to find out, the scientists are trying to find out as to how to make it a smart charging system. There are 2-3 concepts that they're working on. One is the very basic AC charging stations that we have. Second is the DC fast charging stations. Then third is the inductive coupled charging, where the road, a part of the road is, has a track. While the car is running, it can get charged. It's a dynamic inductive coupled charging system.
Electric highway that we call
And
it.
the fourth one is called the battery swapping system. So depending on the advantages and the disadvantages, the people are trying to put up these infrastructure at various places, depending on what is available there and what is the best for that particular location. Now, besides that, when I talk about smart charging means that you need to charge your vehicles when your grid is not loaded. Whenever the grid is underloaded, you start charging your vehicle, and when the grid needs that back, the vehicle can give it back. So that kind of concept is being worked upon. And also these charging, as Dr. Robindro said, we're working on renewable resources. That means you have renewable resources like sun, wind, wherever it is available, whenever it is available. The primary charging will be done from these resources. Only when these resources are not available, you charge from the grid. The third component that we have added in the system is a very interesting component. Like I said, it could be biogas based, it could be CNG based, it could be any other biofuel based, whatever it is, depending on the availability of that thing in that particular location. So the third component we have kept as a variable component, which can be changed depending on whatever is available, easily available. Then in battery swapping station, there's an advantage because you can have these battery swapping station at different places, and these batteries can be charged whenever the renewable resources are available, and these batteries are always available for the battery. To be swapped whenever the vehicle comes into your station. While in a AC and DC charging, of course, you need time. The vehicle has to wait and get itself charged. DC is very good. It has a fast charging, but only thing is there are limitations to the kind of current that will flow to the battery. So all those limitations have to be worked out. So this charging infrastructure, different people are working on different concepts, but yes, it has improved and it is going to improve in future in a big way. And only once we have a good charging infrastructure, I'm sure then the user will have the confidence to go for the EVs. But of course, it should not be taken up as a negative thing. Like people are spreading a lot of things that we are still taking. What is the point? You are still emitting carbon at one point. Of course not. There are a lot of other resources which are available and which will definitely come in the near future.
Like while there's this conversation, like recently we heard that Switzerland actually banned the EVs. So what are your thoughts on it?
Basically, we are not sure of the infrastructure they have, the grid infrastructure. Is it based on the completely coal thermal based on or nuclear or hydro? And the maybe because of their capability to handle the extra load, their grid system is limited, and they have electricity generation limited electricity generation from renewable source. That's why recently they have come up an idea of floating solar power plant on the lakes and the oceans, something like that. So because Switzerland is a landlocked country, they don't have oceans. They have a very small lake near Zurich and some other places. There they are planning to have the water body. They are planning to have the floating solar power plant. That's why that's I think during the pilot project stage. We are not sure that why they are going, because it must be because of their geographical location, because it's landlocked. They don't have ocean, any other resources, and it is a mountainous country, and the availability of sun is also limited because of the shadows of the mountains and everything. So we are not sure of the factors that why they are really doing that, and to add to what Madam said regarding the charging infrastructure, it is not only the lithium-ion based battery that we are going to see in future. There will be multiple players, multiple battery players like metal air, redox, then sodium base. Then even the supercapacitors will play a very major role for the vehicle during charging. So assuming that electric vehicle without battery, only with the supercapacitor, it has other advantage that it can charge in very less time, maybe tenth time of the battery, because it can take very highest current, and it has a cycle charging cycle of around 1 million cycle compared to the battery. Battery has maximum around 3000 cycle. So supercapacitor has a very huge advantage, and the some electric buses fitted with supercapacitor has been tested in China. You have a point A to point B, a bus stop. There you have a supercapacitor charger, and your point A to point B station is defined. How much distance? Everything is done after the study. So you will see the supercapacitor is charged at point A station. Immediately it will charge during offloading and the boarding of the passenger. That time is enough to charge the complete supercapacitor bank. Then from there it will go to the point B station. Then during that entire period, the energy stored in the supercapacitor is enough to travel that much distance. That's why there is no battery use. This type of technology also we can deploy in city areas or maybe intercity, some twin cities. There it is very much applicable. Though it's not that it's the first one. So only thing is that how fast we implement it to save fuels and not to have more carbon footprint. Because India is part of the global, you can say, global platform like COP26. India is a global signatory. So we have a global obligations. Like we have a Panch Amrit. Recently, last year, the Prime Minister announced under this the Panch Amrit, the major objective is that to achieve the net zero by 2070. So net zero is a huge, very huge, vast objective for a country. So people need to understand what is net zero, and to achieve this net zero, what we have to do it from the transportation sector, from the energy sector, from every aspect. So how to achieve this net zero? Because we have a global stake. So India is one of the fast developing economy, and is one of the top 5 world economy. So we cannot be left behind. That's why we have to align and connect the dots to achieve this target. So that is why this different technology has to come and play their role. It's not only lithium-ion battery. So
But that's interesting, because whenever these conversations are happening, one significant question is lithium sustainable? And the point you explained, like, the game is beyond lithium. Like, lithium is an important element, but it's not just only lithium. And also, with the Switzerland banning EVs, there were a lot of conversations around that. Should India learn from Switzerland? Is this even safe? But I think it's good to say that it's not failure of EVs. It's just that, just see what your geography supports. If it's like, what kind of technology does it support, and be conscious enough, be smart enough to play and take that advantage of it.
Exactly.
Like I said, that you should have the flexibility. You should have 2-3 options,
Yes.
and depending on the location where you are, you need to put that particular option, whichever is the best suited for that particular place. And about the supercapacitor and other things, I would also like to say this: IIP is open to test anything that is going to. I mean, if somebody is working on supercapacitors, would like to integrate into our retrofit kit and test it on our vehicle or test vehicle. Not only that, whatever is available, I mean, whatever technology is coming, somebody is working on different type of battery. We approach them, we ask them to give their battery so that we can test them and give them the data, because we are doing the real driving data. We are collecting the real driving data. We have those test cars. We have a chassis dyno, so we give them whatever data is required. So we are actually approaching 2-3 companies who are working on different kind of batteries and also working on supercapacitor. We're trying to make a smart controller, which will decide as to when to take from the supercapacitor, when to take from the battery, and then generate data, and that could be helpful to that particular company.
Yes, and because why we are doing that is that we are trying to support Indian companies, because our whole idea is revolving around AtmaNirbhar. So our EV kits should have, our target is to have 100% Indian components, Indian parts, not the imported ones. That's
and
why
right
the
now,
AtmaNirbhar.
what is the percentage of Indian parts that are present in the
Right now we are the battery is not Indian make, and other parts like motor, other the controller, everything we are trying to indigenize and use Indian make parts. That is where the whole game is. That's why we are supporting and we are motivating the Indian startup companies, and so that they come to this area and have the capability building. Otherwise, until unless we start, then we keep on importing. So somewhere we have to start and then try it ourselves. That's why there are some certain companies started already trying to manufacture a supercapacitor for first time in India. It was never there. The capacity of the supercapacitors compared to other foreign supercapacitors, they are very much the lower side, but still miles to go. We will improve and we will be at par with them at certain point of time. So until we start, we can't compete. So we have to start somewhere. That's why whole idea is to have 100% Indian make parts in our EV kit, as well as in our Indian make EVs. There should be 100% Indian make parts. That is the whole idea.
And where do you see your EV retrofit kit going?
You like to take the call, madam?
Do you have a dream about it? Because you build a technology, and I understand the process, that it's not that it would have taken so many iterations, and it would have taken that courage, like when you were receiving failures ki nahi banana hai. So you would definitely have a dream in mind. Where do you want to see that kit going?
Definitely. First I'll probably add to it. The kind of dream that we have together, actually we discuss things. Firstly, we would like to implement this, though we have made 2 test cars which are 4-wheelers, we would first want to implement this in a 3-wheeler, which is an auto. Because if you go to the cities, you find, except for Delhi, of course, which are all CNG based, but other cities, if you go, they're all overcrowded with autos. And the kind of pollution you get from these 3-wheelers, I mean, it's just unimaginable. So to make the life of the people better there, we wanted to start this with in the Northeast, of course. We want to first retrofit one auto, which can be a showcase or which could be a demo unit, and then we are in touch with, we try to talk to the government and try to see how this can be done and taken up in a big way, that this could be commercialized. And so first we want to start it with autos, actually.
I think that's interesting. Like, I'll just cut you there. Like we did like a series of with auto walas, people making last mile mobility. So we spoke to two different auto drivers. One auto driver who was driving an electric auto, and he was telling that how this electric auto is actually better than the conventional that he used to drive. And the other we talked to was the one who was driving like a CNG based, and he was very reluctant. He was like, "Madam, गाड़ी बहुत महंगी आती है, हम नहीं खरीद सकते और चार्जिंग में बहुत पैसा लगता है." And so it's very interesting कि अगर उसका existing auto ही electric में convert हो जाए, I think that would be a game changer there.
Definitely.
Yes, there is one part, and the coming to that EV, that wire, the roadmap. Actually, regarding this EV kit in India, there were no legislation. So with our work, we could influence the government, and now there is one gazetted notification, GSR 167E. Without such legislation and the gazetted notification from government, our the state transport officials, they are reluctant to re-register and issue your RC to the retrofitted EVs, because there is no guideline. So that's why the first step was to do from the policy point of view. So that's why we could influence and talk to different people, and now we have a gazetted notification legislation in place which allows to convert the existing petrol or diesel the vehicle into electric vehicle, subjected to the type approval as per the AIS 123 part 3. So these are the guidelines. One company cannot simply do and start running it. No, it is subjected to the type approval and a certification from the testing agencies. This was never there, this legislation. With this, it is a legal tool allowing everybody legally and telling the RTOs and EDTOs at the state, okay, guys, you have to allow this retrofitted vehicles fitted with the EV kit to run on the public road. So this is there. It was never there. So that's what I said. We have to start somewhere. Then when we start along the road, we find problems, we find solutions. It's ups and down. So challenges are there, of course. And the roadmap for EV is that we have on road right now around 70 million vehicles on road in India, which comprises around Bharat Stage 2, Bharat Stage 3 vehicles, which are more polluting in nature, which are out of the, you can say, policy, at the verge of end of life and the scrapping. And the government is already banned selling of Bharat Stage 4, I think 2020 onwards. Then now Bharat Stage 6. So Bharat Stage 6, because of technology, it is costlier. And what do we do for all vehicles? What do we do? We cannot simply throw away all these 60 million, 50 million vehicles which are already plying on road. And it has to be either, the very much older vehicle has to be either find a solution to convert it to electric vehicle or to do some repurposing. I will not call it repurposing, so that we save a lot of energy as well as resource. And we continue our journey to as a developed country. That is the idea. And the EV kit has a very huge potential because we have a different vehicle segments. We have a three-wheeler, we have a car segment which is under M1 category. We have then a sedan class, then we have a taxi segment, we have a passenger bus segment. Different vehicle segments, so we need different EV kits. So one single EV kit cannot be fitted in different entire vehicle segments. Like two-wheeler engine cannot be fitted to three-wheeler and four-wheeler. So every vehicle segment has a different engine size. Like that capability. Like that, every vehicle segment will have different EV kits. There is a huge potential and huge research has to be done, and a lot of work has to be done. That is where I would like to put. But what we are venturing into is that we are showing the technology feasibility and the possibility to the people and the hope. And we are doing a very small part in the M1 category. Only very small part, like Madam said, this Maruti Zen is a M1 category, hatchback category, very small car, entry-level car. And the next one is the L5 category, that is driver plus 5-seater diesel autos. That is our next target. So we are not doing big thing, but we are showing a hope and a solution to the public and the entrepreneurs and the companies. Okay, this is doable. This kind of solution is possible, so that we save time, money, and resource. That is how I would put it.
I think, and as Dr. Anjan says, you are actually firing people's imagination. And like, I would really like to say that this is what happens when passionate scientists like you, जब वो अड़ जाते हैं कि हमें ये लेके जाना है. I think that to me, like, it's amazing, guys. Like, I do not like what you have done, like getting it at the policy level, making sure the traffic police, the RTOs understand it. Like, what an amazing effort. And I know it's not easy, but thank you for doing it for India. I have this question because as I was mentioning to you, like there is this like one startup that I absolutely admire that's working in Delhi, Blue Smart. So they have this EV fleets, and there are simultaneously other startups in other states of the India also doing things like that. So do you think that with the retrofit kit, like for example, if we convert the existing EV, like existing, IC vehicles into EVs, the range and everything would be like similar to the vehicle that we purchase, a new EV vehicle to be purchased? Because what I see here as an opportunity is like if these startups convert the IC vehicles into EV with your retrofit kit, they would have like a huge fleet of EVs. Plus, I think the cost would be reduced. So, is the efficiency similar, like to the normal new EV vehicle that people are purchasing now from the market?
Yeah, at the moment, it may not be similar. The new EVs will have a upper hand because right from the design, they are designed as an electric vehicle. So they have put all the inputs and all the considerations to have a highest possible mileage. Maybe one day you will have a 1,000 kilometer run per hour. That will be realistic after maybe few years. So right now, Tata Nexon or maybe you take Mahindra's EV, they have around 300 to 400 kilometer range per charge. It is very good, very quiet amount of electric mileage that you have for a single charge. The day you have 1,000 kilometer per single charge, that's it. That's the real game changing. And we cannot achieve to that with the EV kit. EV kit being the you can say the additional and top up kind of device, which will give a extended life for the existing vehicle. We cannot compete with a new, completely new electric vehicle.
The segment that we are targeting is very different from the segment that you are talking about. The segment who can buy a new car, who can afford to have new EV. It's not easy for everybody to do that. And
it's very expensive.
With which we started is for that segment who really do not want to part away with their vehicle which they already possess. Like the auto drivers, I said.
Yes.
For the auto drivers to buy a new electric one is going to cost them a huge amount. While just to get their existing auto to be retrofitted and to again use it on the road, it may not cost them much and they'll be happy to get it done.
I think we have seen it with the CNG kits and everything.
Years
ago,
CNG
similar
kit,
thing happened.
So that's what I'm saying. The target
Yes.
of the people we are targeting are very different from the people that you're talking about. The segment is entirely different. So we have a huge segment. It's not that, that segment is missing something. We have a huge segment.
It's a very big market size.
It's a huge market actually. Yes. People are not realizing it. EV kit market is very huge because as I said, there are different vehicle segments. You find out the volume which has more demand. Then you venture into that, then you have a huge market.
These cargo vehicles, the small ones which are used to carry these small cargo things, used for Amazon and all that.
Yes.
If they become EV, because there are a lot of them flying on the road.
Yeah, exactly.
So
yes.
that is the segment we want to target on, not on the higher side. The people who are owning EVs and, that's a different segment altogether.
What Madam said is very true because those vehicles, the delivery van and from the Ola taxis and other taxi aggregators, their daily running is very much in terms of kilometer. But the running cost compared to the IC engine and EV is very huge gap because your IC engine running cost, maybe it's a diesel or petrol because cost is almost same. So running cost will be for a car, it will be around 6 to 7 rupees per kilometer. But whereas for the same segment of vehicle in the EV, it will be around 1 rupee to maximum 1.5 rupees. You can see the gap. It's around difference of 5 to 6 rupees. So you multiply the distance you run. 1 lakh kilometer if you run in a month, then you save how many? That's the real.
It's a huge cost benefit.
Yeah, that's the real USP. If you are running 2 lakh kilometer in 6 months, then if it is IC engine, then you multiply 6 into 2 lakhs. You are spending 12 lakh in fuel. Whereas in electric vehicle, you are spending only maybe around 6 lakh. This more than half, more than half the price. So that is why your saving is. that goes into the pocket of the owner and the auto rickshaw driver and the taxi drivers. That is real good. That will boost the economy of the family. Once the family economy is boosted, everybody will be happy, and they will reflect to the national in the larger picture.
I think that's the beauty of it. Like, I always believe that climate action solutions need to penetrate the zones of comfort and convenience, and at the end of the day, it need to empower people's pockets. Yes, exactly. So I think like this is the one element, like you're also focusing on that. I think it's brilliant, like to have that kind of mindset and vision for it. So before we move to our last segment, I would just like to understand from you that how are we going to electrify trucks? Can trucks be really electrified? Because trucks are carrying huge loads, and like how do we electrify trucks? Because I have had conversations with people. Some people say that utna battery we cannot hum truck mein nahi laga sakte hain. And like in India, like huge road transport, like trucks are there. So how is that going to happen?
There the supercapacitor will come play a big role. As I said, your point A station and point B station, for example, it is a truck, for example, goods carrier. Then on the highway, along the highway, you have to have this point A, point B, point C charging points for supercapacitor, not for batteries. So the supercapacitor charger will be a bit bulky and heavier with the high current capability, handling capability. That's why then you move along this. Otherwise, the concept of e-highways will have a continuous flow without stopping it. So this concept and the roadmap, I don't know, it could be a roadmap. The concept was revealed by our Honorable Transport Minister Nitin Gadkari. If this e-highway comes realistic, then your goods carrier, that heavy-duty trucks, no need to have a huge battery or other things. No, you don't need to have IC engine. It can be only on the motor with the e-highways, like you have an antenna touching on the overhead. That is another part. Or you have a supercapacitor bank. You immediately charge within maybe 1 minute, a whole supercapacitor bank. That is the replacement and alternative.
Definitely. And I think Nitin Gadkari ji is doing some brilliant work, and I really wish that he remains in the power really long, because I think definitely has changed.
Because very good.
Yeah, he has very good vision.
Because right now also, as we were traveling from Delhi to Dehradun, I think everyone was saying that look what Nitin Gadkari ji has done. He has changed, like India ki roads kaise dikhti hai. Definitely,
Yeah. Travel time has reduced.
Very convenient.
That is the saving of our energy.
And I think people like me, unko dekh ke hame lagta hai, hame hope milta hai, and we feel that India's transport sector can do crazy things there.
That is the whole idea. You have rightly pointed out rasta dikhana. It is very important, because people are they have a different intellectual level. They may not catch, somebody may not get the idea. If somebody saw a road or a pathways or some possibility, then feasibility, then somebody will catch and do some innovation and make out something better than us or than others.
And he's moving rightly with the science, I would say that, So, the last part is that how can the hybrid charging stations we talked about, how can that it scale in India? Like wherever I go, I have that charging station. How long will it take for that to happen?
See, we are trying our best. Like whenever we are going for a conference or wherever, we are in touch with the people who are into this already. So they are quite interested. We have approached 2-3 stakeholders, and probably it will take us some time to actually commercialize this. Once it's done, they understand the system. I'm sure it's not going to take maybe another 2 years. I see a future for the charging infrastructure, that to renewable one.
Yeah, you can consider as a risk taker, because private companies are very reluctant to take risks, and we are just showing a solution. We are not a production company. We are research, and we are showing a solution from the research point of view, research perspective. So we take risk first step. Then when we try to show it that is possible, that is a solution, then we tell them you follow it and let's do it together. That is the way we are trying to do it. If the companies don't follow and don't come with us, it goes nowhere actually. So they have to come and they have to take some risk also. And without investment, you can't expect profit, no? So somewhere you have to invest.
To showcase whatever we have, because the demo unit is ready. So now we are in a more comfortable position. Whoever comes can visit and see exactly how it works. So this is what we are now trying.
Yeah, exactly. There are always technical challenges always from time to time and from location to location. And then technical challenges, we have to keep on solving the problems so that we have a very robust and very reliable charging infrastructure as well as EV kit. that is Make in India. The whole idea it should be in Make in India. Either it is a charging infrastructure or EV kit. The maximum component used must be Make in India. That is where then only we can have the circular economy. Otherwise, our money will go out of our country.
So thank you guys. Thank you for doing this. And
Thank you so much,
I
Poonam.
think this is like the real power of India, and that is how India is going to become self-reliant, and as we call it, Atmanirbhar. So thank you for doing what you
Thank
were
you
doing.
so
Thank
much.
you
Thank you
so
so
much
much.
for
Thank you,
being with
madam.
us today.
Thank
Thank
you.
you.
Thank you.